Okay, so good morning everyone. Here we are back with the week 2 assignments of AI representation of logic and reasoning. So the question first is a sentence in a logic is a statement that in principles has a true value. Which of the following are sentences in logic? So it is saying which are direct truth statements. So this is a question. It can Joey said he will not pardon his son. It is a statement, so it is true. Joey didn't not pardon his son. It is a fact. It is also true. Please sign a law binding. Please, it's an order, not a true. It's a request only. Government signed a law binding voter ID. So it is a fact. Now it's true. In reasoning, the lead to logically sound arguments are its deduction, not abduction. Select the formulas that are tautology. I have made this table, truth table, and then these are the valid tautologies. Here it is asking which is satisfiable. So in satisfiable, it is written that at least one argument must be true, and in tautology, all are true. So after doing this, PQ derives R. We can say that this is satisfiable and this is tautology. Here the valid rules of substitution. If we substitute here this, the tautology or anything in the truth table will be equivalent. So these are the true answers. Select the valid rules of inference. If P implies Q is given and then P is given true, then we can derive Q is also true. If P intersection Q is given, we can imply P union Q. If P implies Q is given, we can derive P intersection Q implies R. It can be solved after making a truth table. Since I don't have that much of time to make, let's go on another question. Which of the following sets of connectives are complete in propositional logic? So we know that NAND and NOR are complete gates. Then if this intersection and negation is given, we can also make every gate, and if union and negation is given, we can also make any gate. If implies and negation is given, we can also make any gate, but it is only single unit. A knowledge base written in a logic language is, so a knowledge base is a statements collection of statements where all the values are true. So it is a set of certain where all the statements that are in the set are true. Propositional logic, what does it means to say that KB entails P symbolically represents as this when all the sentences in KB are true, then P is necessarily true. One can derive P from the sentences of KB, so both are true, solve the above. This means derive. It's a subset of entails. A proof of derivation in logic is. So it is saying a proof or a derivation in logic is what? Like this. A synthetic process that uses inference rules to generate new formulas from existing formulas. Okay, a synthetic process that does not bother with the true values of the statement that are begin, read or derived. Both are true. An evaluation function that uses the true values of the existing formulas to derive the true values of new formula. Here, an evaluation function that uses true values from existing formulas to derive new formulas could be true. I have a little confusion in this, but how can it know true values from new formulas? It derives anything. We cannot check is that true or false. Here we have sound and complete. So what soundness says? Every derived formulas are true, then it is sound. So derived formulas are true. In A, it's true, so it's true. In B, derived formulas are not true here, so it is not sound here. Derived formulas are not true here, so it is not sound. This is all one subset, equal subset, so this is sound. In completeness, it says all the derived values are true, so here derived values all are true, but it is not deriving all true sentences. So here it is not complete. Here derived are not true here, so it is not complete. Here we can see that derived statements are including all true statements, so it is complete. And here it is a merge of true and derived statements, so it's are complete. Now there is a dry vegetation. D denotes there is a wildfire. From this we can imply this: if there is a wildfire, then houses will burn to cinders. The houses were burned to cinders. Therefore, there was a wildfire. So this is modest D implies it cannot derive this. So it is not valid. Here, wild there was a wildfire, then houses will burn. The houses didn't burn, they remain intact. So we can conclude there was no wildfire. Yes. We must have fire insurance, or he must have used savings. He has zero savings. Therefore, he has a fire insurance. So this is F union S as we cannot derive this. Therefore, he has fire insurance. He has zero savings. We have negation this given as true. So it for true, it must be true. He has fire insurance. If the following arguments valid, he must have fire insurance or he must have huge savings. He has massive savings, therefore he has this is also this is given. Can we inference this from this? It can be or it may be also covered. So here no is the answer. Frege proposition calculus can only uses implies and not, which are universal. Modus ponens is a valid inference rule.